Happy Tuesday, guys. Sorry again I couldn't be here. I'm at a meeting over at BEC, but I feel pretty confident about this lesson that you will be able to work the homework and the stuff I have prepared for you after you watch this and work some of these examples with me. So we've done exponential growth. We did exponential growth last Thursday and Friday. Yesterday with the zombie apocalypse problems, that was exponential decay. What happened after each day was that the number of people that were left living went down, 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 just kept going down until we just had just a few left. And so that was the whole idea behind it. So let's look at the growth problems. I'm just going to pick up some growth problems that we did last week. For instance, some exponential growth functions. So we might have had like y equals 3 times 2 to the x. Or we might have been f of x. That's just a fancy way of saying y. Would be 5 times 8 to the x. Or we might have had f of x equals negative 1/2 times 10 to the x. So even though there's a negative in front of that, it was still growth. The whole idea with it being growth is that whatever is being raised to a power is bigger than 1. As long as it's bigger than 1, even if it's 1.1, that's bigger than 1, it's going to be exponential growth because that number is bigger than 1. Okay? So with decay functions, what we are looking at is just making it so that number being raised to a power is less than 1, or I guess said more appropriately is between 0 and 1. Okay, so we might have like y equals 4 times 1/2 to the x. Now don't worry about the number in front. It can be anything it wants to, but the fact that what number is being raised to a power, what number is being raised to the x power is between 0 and 1, that's what makes it a decay function. We might have f of x equals 10 times 2/3 to the x. That's perfectly fine. Even again, like I said, if there's a negative in front, let's see, I'm going to choose a weird one. 16/25. You might see some parentheses there since that's a fraction. But yeah, that would be a decay function because everything being raised to a power is between 0 and 1. Now you graphed one of these yesterday in your zombie apocalypse problem. I'm going to give you just the basic shape of one. Okay, so I'm going to put a point here. I'm just going to make up a point here to make it so it doesn't go through an actual point like I had last time. So it's just a mirror image in the y-axis from what we saw last week. Last week we saw it coming up to the right. Now it goes up to the left. Okay, so my decay function, it is a decreasing function. What I mean by it being decreasing is that as I look at this from left to right, if I was to put, I don't know, I drew those a little high. If I was to put a little guy on a skateboard on here, okay, he would be decreasing. He would be going down the pipe there, the half pipe, to as he went from left to right. Okay. On this basic function, and again, I'm graphing y equals, I'm just going to say b to the x. On this function right here, it's going to go through the point 0, 1. So it goes through the point 0, 1. Okay. Now, if there's a multiplier in front of it, like if it's a times b to the x or something else in front, then yeah, that's going to stretch. It's going to move up and down. It might reflect down, but the basic function that we're going to be dealing with in our table is going to go through 0, 1 still every time. As you can see, everything else is just kind of flip-flopped. Okay. Instead of going through the point 1 and then whatever the growth factor is, it's going to go through the point -1. whatever the growth factor is, since it's flip-flopped from what we did last week. And we're still not touching the x-axis. That's going to be a no-go on that. The x-axis is still going to work as my horizontal asymptote. And so what that is doing is it's modeling the behavior of the graph as I exit the graph on the left or right side. So this blue line gets closer and closer and closer to the x-axis, but it never quite touches it. Okay? So let's try some together, and then I'll turn you loose on some to do where you can check your answer with me. Okay? So I'm just going to keep it basic right here. Y equals 1/2 to the x. Now, my biggest fear is that you're going to confuse this with what we did last week. And so I've tried to make it so this table is foolproof where you don't have to worry about that whenever you get your 3 points. Now, I still think it's going to be easier starting at the bottom down here with 1. If I plug 1 in for x, of course I get just 1/2. 1/2 to the 0 power. Well, anything to the 0 power is 1. And then 1/2 to the negative first power. How does this make sense to you? Remember, if something's raised to the negative power, whatever's in the denominator comes to the numerator, and whatever's in the numerator goes to the denominator. And that gets rid of the negative. So this is just going to be 2. So you would be correct in assuming that these two are just going to be multiplicative inverses of one another. You can just flip-flop them and take the reciprocal. And that will work on these. So I'll plot these 3 points. It's going to be here, here, and here. And sure enough, my graph looks like what it did on the last slide. With my horizontal asymptote. I'm not going to be touching. Let's try it with a number in front. It's just a multiplier. We kind of know now that we've done last Friday, we know that that number in front is actually going to be my initial value, how much I start with. Okay, we might talk about that in just a minute if I remember. So I'm just going to start with my XY table. But remember, I'm going to use the same rules I did on this last Thursday. I want to make it so the only thing I'm going to be plugging in is something raised to a power. I don't want to mess with that 2 just yet. So I'm still going to plug in -1, 0, 1 in for my x. So 1/4 to the first power is going to be 1/4. 1/4 to the 0 power is going to be 1. 1/4 to the negative first. Again, you're just flip-flopping here. So just take that 1/4. Let's just call it 4. Now I'm ready to take care of this 2. I'm going to go ahead and multiply by 2. All right. So that gives me 8 and 2, and then 1/4 times 2 would be 1/2. So I'm actually going to be plotting these points. Okay, so -1, +8. That's going to fit 1, 2, 3, 4, 5, 6, 7. Uh-oh. We'll extrapolate just a little bit. 0, 2, and then 1, 1/2. Remember what we said last week? We said this was going to be my initial value whenever I was figuring out how much something appreciates in value and its exponential growth. And sure enough, it's still my initial value. It's just always going to be my y-intercept right there. I'm going to try to draw this. I'll start from the bottom. Go all the way up. So I'll be checking these points to make sure I didn't go through 0, 2. You guys not even going to tell me about that? Let's try this again. 0, 2. That might make it a little easier. 1, 2, 3, 4, 5, 6, 7, 8, and 1, 1/2. All right, that makes it a little bit easier to get to all the points. There we go. I like that one. And that would be my graph. Like I was about to say just now, I'm going to be checking to make sure you're in the right spot right here. And this guy is growing at this rate, way up there. All right, your turn to try it. Okay, here's how this works. You're going to go ahead and make your table, plug everything in. Actually, before you do any of that, I want you to hit pause. And I will work it while you have the video paused. Come back and hit play, and we'll see if we have the same answer on this and we have our points in the same spot. Our table is looking the same. So go ahead and hit pause, work it out, and then hit play. There's a little bit of a trick on this one. This one took off really fast on that left side, didn't it? Negative 120 was the point that I got. So what I did was I scaled my y-axis by 5. And to show that, you can see that I put these 5s in here. Unless you just have like a large amount of graph paper and you want to draw that all the way up there, doing this is perfectly fine. Just make sure I can easily tell what you scaled your axis by. Okay. Now, there are some real life situations that something does exponentially decay. We talked about growth, and we said finances, and what else did we say? Finance was a big one. Population, that was a really big one. But stuff also exponentially decays, like the value of electronic equipment, the value of vehicles. We're going to see that in just a minute. What else does? In chemistry, all those chemicals that you deal with, they have something called a half-life that makes it so it constantly is decaying, coming down. And so those are some examples of stuff that decays exponentially. You'll see some more in your homework that the sub has. But my exponential decay model, I hope that it looks familiar to you. Let me make sure I'm using the right one here. Okay, I'm going to use y equals a times 1 minus r to the t. I hope this looks familiar to you. If it does not, please do your homework from last week. If it does look familiar to you, you can just tell that the only thing that we are changing from last week is making it so this is a minus sign. Remember, I want to make it so whatever's being raised to a power is between 0 and 1. So I'm just going to subtract whatever my rate is from 1. A still stands for the same thing. A is still going to be my initial amount. Okay. My R is my decay rate. And then T is going to be the amount of time. This does not have to be in years. It can be in weeks. It could be in days, and so forth, all the way down. So that's going to be the amount of time. So let's try it. Now, this isn't my Durango. This is Mr. Noise's Durango, okay? He says it was worth approximately $25,000 in 2003 when it was brand new. Now, this probably isn't too far off. Every year, it depreciates by 15%. So he's asking, how much is this going to be worth now? All right, I'm going to go ahead and grab my formula from the last slide. 1 minus r raised to the t. And then y, again, is going to be my answer. We can't really solve for too many other variables right now. So for now, we're just going to be solving for y. Okay. A is my initial amount. That's the first amount that I had on the Durango. Well, the first amount I have on the Durango was in 2003, whenever it was worth $25,000. Okay. 1 minus my R. My R is going to be this 15%. That it's going down every year. Then it's going to be raised to the T. How much is it worth now? Well, it's 2019. I don't want to plug in at 2019, but instead I want to plug in the number of years it's been since the Durango was worth this $25,000. So if I just do some subtraction here, 19 minus 3, it's been 16 years that he's held on to that Durango. So now this just turns into a calculator problem. If you want to simplify some stuff, you most surely can. 1 minus 15% is 85%, meaning that the Durango is going to hold 85% of its value each year. Okay. I'm going to need to grab my calculator real quick and plug that in, and I'll be right back. All right, typed everything in, and to the nearest cent, Mr. Noise's Durango is only worth $1,856.28. There are a couple things I want to be clear on this. I was looking at your worksheet. The decay factor is going to be this whole amount right factor. This is actually known as the decay factor. Whereas the percent that it's going down each week, that is known as, or each year, I guess, is the decay rate. Okay. On your worksheet, it's going to ask for both of those, so make sure we have that difference down. Okay, I want you to try one of these on your own. Well, again, we'll do the thing where we pause the video, and then we will see if we get the same thing after you work it out. So go ahead and hit pause, and then give this one a shot. These snowmobiles hold their value a little bit better. It's like in the Dodge Durangos. $3,061.80 on this answer. Hope you got that. That is all I have on these slides. See the sub for your worksheet packet. You should be able to do that first homework assignment. Have a great day.